And here we go. We are live. Welcome everyone. Welcome all our VJUG members. Welcome to December. And December is a special themed month for us. And we're going to be talking about a bunch of alternate JVM languages. So before into that, first of all, I just want to say hello to Will Smith. we were talking about this offline. The translation is Will Smith. Guillaume, how are you doing?
Yeah. Hey guys. Yeah, Guillaume Laforge. That could be translated to Will Smith in English.
Guillaume,
not the usual Will Smith, but well.
And I think it should be at every opportunity.
And Guillaume, please introduce yourself. Tell us what your relation with the Groovy Languages.
Yeah. So I've been working on Groovy for the past 10 years, actually, pretty much since the beginning of the project. And so I quickly became a committer on the project, and as the founders left the project, I took the lead of the project, and since then I've been working on Groovy, spreading the word and the love of Groovy at conferences here and there, etc.
Awesome. And also we have Oliver with us today. Hey Oliver, how you doing?
Hi guys, great to see you, Guillaume.
Yeah. Hey.
You know, I'm reminded that Guillaume and a couple other guys from his team helped us out when we were making the adventurous guide to JVM Languages, and that's when I think that's when I first got to know Guillaume, and I was always thinking that the Groovy guys were pretty much the fastest, most reactive guys from all the languages that we talked to. In fact, I think we had to leave out some of your quotes. So it's great to see you again, and I'm really looking forward to this session.
Awesome, thanks, Oliver. So yeah, just to let everyone know while we're getting everyone joining up and getting online. And this is the first of 4 sessions that we have. We also have, and I'm not going to give you the order because I can't remember them, but we also have a Scala, a Ceylon, and a Kotlin session in December. So it's going to be great fun to experience the alternate languages and see how ready they are for adoption, both in terms of a hobbyist style language with perhaps some of the newer ones, and also maybe looking more to production with a Groovy or Scala that have kind of been around for a lot longer. We also have Mr. Oleg on offline, which he's doing a whole bunch of tweeting, and I know he's super excited to hear from Guillaume about Groovy. So hey Oleg, I know you're with us. So without further ado, Guillaume, I'll pass over to you.
Okay, thank you. So let me share the screen. Up, and the slides are here. Okay, so you see the screen?
Yep, everything looks good.
Okay, so I'm going to make an introduction to Groovy, and I will highlight. So it's not going to be a full comprehensive overview of each and every little detail of Groovy, but after a bit of background, an introduction for Java developers, I'll also highlight some of the key features that I like about the language, like the little gems of the language. So that's why I call that presentation "What Makes Groovy Groovy." So as I said, I'm Guillaume Laforge. I'm leading the Groovy project. In a nutshell, Groovy is an open source project. It's an alternative language for the JVM in the sense that the JVM is a platform that is able to run Java, of course, but other languages as well, as long as they can be interpreted or as they compile to the bytecode that can be understood by the JVM. That's the case with the Groovy language. In its nature, the nature of Groovy is to be an object-oriented language. So everything you know about classes, interfaces, abstract classes, enums, annotations, etc., all the object-oriented concepts of Java are basically the same in Groovy. although we go a bit further with traits. Groovy 2.3 introduced the notion of traits, so it's like Java plus some additional stuff. Groovy is also a dynamic language in the sense that by default all the method selection, method dispatch, etc. is done dynamically, so we don't encode in the bytecode okay, call that method directly. Instead, we call the runtime, the Groovy runtime. But there's also the option to do that statically. We'll mention that later on. It's also a language with a functional flavor in the sense that we have closure as a first-class citizen element of the language. We've got all sorts of useful methods for working with collections, etc., to do map, filter, reduce kind of work. So we will mention that as well in the presentation. Beyond that, although it's a dynamic language, we also support both static type checking and static compilation. Static type checking, which gives the same, I mean, for the Groovy compiler to give the same kind of feedback that the Java-C compiler gives when you make a typo or return a wrong type according to the return type of a method, etc. Once code type checks, we can also statically compile it to generate pretty much the same bytecode as Java-C, which means that Groovy can be as fast as Java as needed if you enable static compilation. So that's a bit, well, let's call it a definition or a brief description of the language. Now, let me tell you a bit about the vision we've had behind the project, behind the language. So the key thing we've always had in mind was that we wanted to help Java developers and try to simplify their lives by making certain things which are painful to do in Java to make them simpler in Groovy. So we tried to provide easier shortcuts for common APIs, or like we will see in the first bits of code samples, like supporting properties, because Java properties are a bit verbose, you know, with getters, setters, etc. So we try to make the code more concise and make developers more productive. That's the goal of Groovy, to make life of Java developers easier and simpler. Groovy is also pretty easy to learn because it looks pretty much like Java, so it's pretty much a Java superset. There are some differences, but just a few of them. So 95% of the code you would write in Java is also valid Groovy code. So it's easy to learn, but as I said, we try to provide different API wrappers around things like, let's say, the JDBC API or XML parsing, etc., to make things much more concise and easier for the developers. We really try to give powerful tools to our users so that they can get things done more easily and faster, and they can focus on the business side of their application. Groovy is also a pretty elegant language. I'm going to show you an example here of the Spock testing framework. That's an example of a framework. So it's built on top of JUnit, and it shows how it somehow hijacks the syntax of Groovy to be able to write tests in a pretty elegant way, I would say. So we are reusing labels to distinguish different parts of the test, like, okay, you're going to expect a certain assertion to be true, and there's a where block which uses a kind of, you know, table wiki-like notation to do data-driven tests. So we'll fill in the values of A, B, and C from the table at the bottom of that example. Also notice, for instance, that you can use strings for method names instead of, you know, using a camel case method name. Here you have the real label, you know, maximum of 2 numbers spelled in correct English with proper spaces, basically. So it's quite elegant, and Spock is really a nice framework. It works well in the IDs as well, because it's based on JUnit, etc. I mentioned static type checking and static compilation. Sometimes people think that, you know, it's a dynamic language, so it must be slow like a snail, but you can make your Groovy code as fast and as safe as Java if you use static type checking and compilation. We'll come back to that a little bit later on. I have a few figures to mention in terms, for instance, of performance. Last but not least, it's a language which is quite flexible. So here is an example of a dynamic feature, the markup builder. It's a class from the Groovy SDK, which allows you to create any XML payload. So it's reusing closures. So the curly delimited blocks of code are actually closures. The interesting thing is all those methods, HTML, head, title, body, div, p, etc., are actually, they are not existing methods on the markup builder class, but they are somehow intercepted by the Groovy runtime. And the Groovy runtime, the Groovy underlying API, knows that there's no method called HTML on markup builder, no head method, etc. So it figures out that it should be creating a tag, an XML, an HTML tag, etc. Also notice that you can drop some parents like around those strings there, or you can use named arguments, so you can have attributes for the div tag, etc. And ultimately it's going to create the HTML content that you expect. And the nice thing with that builder approach, so it's not the builder pattern like Fluent APIs, but it's the Groovy builder pattern in the sense that you see the nesting of those tags if you follow the nesting of the curly braces, basically. So you see already the structure of the HTML you're going to generate. And it's a dynamic feature. We could do that with a static builder as well, but here in this case that's a pure dynamic feature. Another example of flexibility, it's also in terms of syntax plus some conventions. So this sentence, move forward at 3 km/h, it's actually valid Groovy code, and we'll see in this presentation a bit later how we can write that kind of code. And also how you can add properties to numbers, like 3.km, it's adding a property to a number. Groovy's got various tricks under its belt to be able to write such things. And that's this flexibility in terms of syntax, call conventions, etc., is also one of the reasons why we have many companies using Groovy sometimes as an embedded business language to write business rules. And another example of conciseness this time, that's the Spring Boot opinionated version of Spring, if you will. When you use Groovy, you can even write a hello world application in the span of a tweet in less than 140 characters, and it's a full-blown, you know, hello world web app basically. So it shows that Groovy can be pretty concise for some mundane tasks as writing a hello world web application. And I'll finish with some more elements around the success of the project. So Groovy is a pretty popular project. Last year we had 3 million downloads for an open source project. It's quite a big number. Up from 1.7 million the year before that, and this year it will be at least more than 4 million when I looked at the stats a few weeks ago. So it might be between 4 and 5 million downloads, so it's still on the rise. And it's used in different contexts. It's great for scripting, when you're scripting, you know, on your within your shell. Things you would have done perhaps with Bash or even Python or Ruby, you can do that with Groovy and even leverage existing Java libraries. You can use it for domain-specific languages because of how the syntax and the APIs and the meta programming capabilities are flexible. You can use it for integrating, mixing Groovy and Java together, because Groovy has got in my opinion, the best integration with Java. So you can really mix and match Groovy together, like having a Java interface being implemented in Groovy, and then you extend that Groovy class in Java. You can mix and match the languages really, together. And you can also write full-blown applications, desktop apps, web apps, reactive apps, etc. By using just pure Groovy. So it's not just integrating Groovy in a Java application, but writing full-blown apps. And we'll mention at the end, in the last section of this presentation, a few of the more famous frameworks and tools from the Groovy ecosystem. And there are plenty of folks actually using Groovy. So all these companies, in a way or another, are using Groovy. So that's quite a few. I'm sure you'll recognize some names there, let's say Netflix. It's probably the most web-scale deployment of Groovy, in the sense that every of the, I think they've got 50 million customers, I think. When anyone watches something on Netflix, it's being routed through some Groovy logic, some Groovy dispatch, Groovy scripts. So it's probably one of the largest scale deployment of Groovy. And there are in those names here, there are also some financial institutions dealing with literally billion euros worth of money monthly. For instance, there's an insurance company that deals with $1 billion worth of loans every month, thanks to Groovy business rules. So that's the kind of stuff folks are doing with Groovy. Okay, so now that I've set the background, let's look more closely at what Groovy looks like, especially for those who are less familiar with Groovy. So as I said, most Java code is pretty much valid Groovy code because of how the grammar of the Groovy language is close to the grammar of Java. So that's why sometimes I say that Java developers are already Groovy developers without really knowing it. And so it's not because you're going to die if you use Groovy, but I was looking for a picture with a flat learning curve, because Groovy provides a flat learning curve for Java developers. And as I said already, it's easy to learn. So let's start with a hello world, right? So the example above is Java hello world, public, class, main, public, static void, main, string, arg, system, arg, println, hello. You just wanted to say println hello. So the above example, it's a Java program, but it's also valid Groovy code. But as you're going to know more about Groovy, you're going to write more idiomatic code, and ultimately you'll be writing println hello in a script rather than wrapping everything inside a class like in Java. But the top example is also valid Groovy code. So Groovy is also a scripting language in the sense that you don't always need to have the boilerplate surrounding class structure. You can just put freestanding statements like println hello, and behind the scenes it's generating a script class. But well, that's the first little taste of Groovy, to just say hello world, hello virtual jug. I could have printed, that would have been more appropriate. Next, beyond Java, we made various things optional. So semicolons are optional. You can drop your semicolons. Top level parentheses can be also omitted. The return keyword is omitted. The public keyword and typing. The typing style of Groovy is optional typing. A bit like in there are some other languages that feature that kind of typing. Let's see that more concretely. So let's go again with the Java examples. This is a greeter Java bean. So we've got a private field, we've got a getter and a setter for the private field. We also have a greeting method, a greet method, which takes a name and returns some string. And then somewhere else, or in a main method, you're going to instantiate the greeter class, you're going to set the owner, and then you're going to print the result of the call of the greet method, passing a parameter, here the name of my older daughter, Mario. So this is a valid Java code, basically. If you put that in a Groovy script, this will also run, and it will print, hello Marion, I am Guillaume. So let's try to make that example a little bit groovier, okay? So first of all, I said we can omit the semicolon, so you remove the semicolons, and it's still going to print the very same message. Next, you can remove some of the parentheses, so like the top level parentheses around the println call, or the set owner, the parents around the Guillaume parameter. You can drop them. The return keyword can also be omitted, so the last expression of a method is what is going to be returned by default, but you can obviously use the return keyword explicitly. So here I can remove this one and the one above from the getter. Next, I'm going to remove the public keywords, because by default, when you create a class, when you create a method, you usually want them to be useful and to be used by other classes. So by default, we decided to make classes and methods public, so you can remove them. But obviously, if you want to have a protected method, a private method, etc., you can be explicit and use the usual modifiers. Next, what we call optional typing, so you don't have to repeat the type information all the time. So for the definition of that greeter local variable, you can say def greeter equals new greeter instead of repeating the type. You could also put def for the private string owner field, or you could use def inside set owner, or the parameter, or the parameter of the greet method, etc. But usually my advice is to have a good API with types, so that it helps IDs, it helps for documentation, it helps for things like code completion, etc., and also for interacting with Java. So it's usually better to have a strong contract with types, and inside the body of your methods, for instance, you can use def pretty much anywhere you want. So that's some advice that I'm giving, but it's up to you to decide your own style. Next, we already saw it. There's a handy shortcut for the println method. So we can just say remove system out and just use println. As I said, we have the notion of properties in Groovy. So instead of having a private backing field and a getter method and a set owner method, you know, it's a bit verbose. So you can just remove all those getters and setters by just making the field here without any visibility. And actually, when you put that field without visibility, the Groovy C compiler is going to generate the getter and the setter. So the methods, the getter and setter, will be present in the bytecode. It's just that they are not, you don't have to write them yourself. That's the job of the compiler to do that. You will notice, I'm sure some will notice that or will have that question in mind. If you remove the modifier here, it looks like a package scope field, but actually it's a Groovy property, it's not a package scope. So if you really wanted to have a package scope field, Groovy has a special annotation called @package_scope, which makes a field package scope, basically. So that's one of the little differences with Java here. Next, about properties, you can use the property notation. So instead of saying set owner, you can do .owner equals Guillaume, as if you were accessing somehow a public field, although it's not a public field. Another handy shortcut is that you can use the map-based constructor. So you didn't define map-based constructor or named argument constructor, but what Groovy is doing there is that it's calling the default constructor, and then in turn calls the setter, the set owner, with the Guillaume string there. So it's a shortcut for what you were seeing before. What else? Yeah, we also have interpolated strings. It's a sexy feature of the language, also known as G strings. So instead of doing string concatenation, you can use this notation with the dollar placeholders. And obviously, the name and the owner placeholders will be replaced when you return the value here from that method. So to summarize what we did, so let's reformat that a little bit. So it now looks like this. But we started with something a bit more complicated. We had like 2, 4, 6, 8, 10, 11 lines of Java code. And we end up with those 2, 4, 6 lines of Groovy code. They are equivalent. That's the same code, that's the same bytecode which is generated, but it's a little bit shorter, a little bit more concise, and you focus on, let's say, the business method. If the greet method is the business logic of your class, as simple as it may be, you can see more clearly what you intended, what you wanted to write. You don't have all the boilerplate code like semicolons, like getters and setters, and you have shorter code. So this is how progressively you can turn Java code into Groovy code as you learn more about Groovy. But beyond that, it's not just simplifying the Java syntax, but we're also extending the syntax with new features, with native syntax constructs like closures, lists, maps, etc. So let's have a look at that. We'll start with closures. So closures are really a first-class citizen of the language. Closures are delimited with curly braces. You can have parameters A and B, which are injected with this arrow notation into the body of the closure on the right side of the closure expression. You can assign a closure into a variable because we have a closure type. Here, you have a real adder object which has got a call method, but there's a shortcut so that adder call A and B is actually shorter if you just say adder parents A and B. So that's the short function call form, basically. And also notice that this example, this closure, is more polymorphic in the sense that you can pass things which can be added together. As long as your types have a plus method somehow, strings can be concatenated, numbers can be added together. So you can also create your own operator of loading logic. If you have some type with a plus method, you can use the plus sign, the plus symbol. So that's interesting because you can pass numbers or you can pass strings, so it makes things more polymorphic. But you could also decide to be explicit with the types and say int A, int B instead of just A, B. And in that case, that's a closure which accepts only ints, obviously. Another thing is, so you saw the two parameters, A and B, but we also have a default parameter, an implicit parameter, which is called it. It's not a keyword in the language, but by default, if you don't name the parameter of your closure, there's a default name. It's called it in the context of the body of that closure. So here, it times 2 is going to double the value which is passed as parameter. So you call doubler with 3, it's going to return 6. 3 times 2 equals 6. I got the math right. And Groovy also adds a multiply method on strings. So if you multiply a string 2 times, it's going to repeat the string. Because Groovy actually adds new methods on types. That's what we call the Groovy GDK, the Groovy Development Kit. So even on classes which are final, etc., we kind of decorate existing types from the JDK with additional methods. So we have a multiply method added to strings, so that string multiply some number is going to repeat the string a certain number of times. That's a dynamic aspect of the language, but which also work in a statically compiled context. To continue with parameters, you can also have varargs parameters. So if you want to pass 0, 1, or more parameters to a closure, you can use the triple dots, and you can also specify the type if you use int triple dots, if you want to add only ints. We also have default values for parameters. So here we have a mult closure, which is going to multiply a and b. And if you pass 2 parameters, when you call mult 2 times 3, you've got 2 into a and 3 into b. 2 times 3 will be 6. And if you pass just 1 parameter, the 5 value here will be put into a, but then there's no second parameter, there's no b parameter, so it will use the default value, so 5 times 10 will be 50. So this is the default value, and yeah, that's the provided value for b. Also notice that it's carrying or partial application. It's working from the right side of the closure, but you can also do partial application with a special method on the closure. So there's a dot curry and an r curry and n curry to curry just the parameter you decide more explicitly by the left, the right, the middle, or using an index. You have some control over the what default value is used for this or that parameter. Next, closures. So we have as I said, a type for a closure type. And we've got this notation $ampersand, which somehow gives you a kind of pointer over an existing method. So this gives you, the first line gives you a pointer over the log10 method of the math class. Or you can also get the println method into a closure printer. So you can then use your own closure here, log base 10, you pass 10 equals 1, and then the printer closure, you can pass a string and print that out. That's also interesting when you implement the strategy pattern. If you want to pass some logic around, you can pass closures and pass different strategies in the form of closures, which are actually pointing at some methods on some of the types. So that can be useful at times. And so I'm going to give more details on this example that I'm going to show you now. But here I'm creating a person class with a name property and an age property. Notice that we use the immutable annotation. I'll come back to that later on. So it's transforming that class into an immutable class. I haven't introduced the notion of the syntax for lists, but what you see here, it's a list of persons. So lists are delimited, surrounded by square brackets, and elements are delimited with commas. And what's interesting is this, all these methods like find all, collect, etc., which are actually added or which are decorating Java collections. So you can find all the persons who are below 18. You can collect their names in uppercase. You can sort those names and then join the names. Obviously, that's a map, filter, reduce kind of stuff. And the result of that little filter reduce operation is the first names in uppercase, sorted alphabetically, separated by a comma and space. And actually, Groovy provides tons and tons of useful methods, like find all that we saw, group by, if you want to group persons by their names, if you want to create combinations, if you want to count elements by a certain criteria, if you want to create all the subsequences of a collection, if you want to transpose, like when you transpose matrices, etc. There are tons of useful methods that are provided by the Groovy development kit. Another thing with closures is some of the methods from the GDK, like with reader, which is a method on file, which is also available on the path as well. So it creates a reader over a file. So the closure that is passed to that method gets the reader of that file. And what's interesting is that when you enter the body of that closure, you've got the reader properly instantiated and so on. And at the end of the execution of that closure, Groovy will take care of closing the resources for you. So it's not going to be yourself that's going to have to close the streams, clean up the resources, etc. That's the GDK that does that for you. The implementation of the with reader method does that. Similarly, we have the with writer method, which creates a writer for an output file. Then I can read each line of the reader, and for each line I see if the line contains the word Groovy, and if it contains the word Groovy, I'm going to print the uppercase sentence in the output file. I'm not sure that there's a lot of mentions of Groovy in the Bible. That was just for the sake of that example. So what's interesting here, remember, is that closures can be very useful for resource handling, cleaning up resources, etc. And you can write such methods yourself, so that in your code base, you don't have to litter your code with exception handling, opening, closing resources, etc. And you might be wondering about closures versus Java 8 lambdas. And also, I mentioned the map filter reduce methods. You can also think about the stream API from Java 8. And actually, so here's two examples for Java 8 with lambdas in the API. So here I have a range of numbers, and for each number I'm going to print the number with the lambda expression. Here I have the list of lines of a file. I'm going to transform them in uppercase, and again I'm going to print each of them. What's interesting is that Groovy, although we don't have the same syntax, we don't have the lambda, the Java 8 lambda syntax, but you can use Groovy closures wherever you would use a lambda expression. So it means that you can already use the stream API with Groovy closures right away. So we actually have a similar mechanism for transforming a closure into a functional interface. And actually, Groovy goes a bit beyond, because we also support some types, single abstract method types. So this mechanism of transforming a closure into some type also works for abstract classes with a single abstract method. So you can use functional interfaces from Java 8 and other frameworks and libraries, but it also works with abstract classes as well. So you can just use Groovy closures in lieu of Java 8 lambda expression and use all those APIs like the stream API, etc. from Java 8. One of the last bits about Groovy closures, it's let's call it a convention or a syntax convention. When a closure is the last parameter of a method call. So here you have an unless method which takes a Boolean condition and a closure. You can put the closure outside the parents. So you can say unless 10 smaller than 9, and you pass the closure after that. So it's equivalent to saying unless 10 less than 9, comma, the closure. But you can put that closure outside of the parents. So if you look at it, unless this construct looks like an if statement, basically, but you invented somehow your own custom keywords. So that's handy for DSLs, for domain-specific languages where you want to have your own control structures, like if you have a behavior-driven development kind of tool, you want to have a given when-then block using Groovy closures. You can do all sort of things to create your own custom control structures, thanks to some nice syntax conventions. And interestingly, this feature has been borrowed by the Apple engineers in the Swift language. So they call that trailing closures. So when the closure is the last element, you can put that outside of the parents. And actually, interestingly, Apple borrowed some other features of the Groovy language, like we'll mention that later on, the question mark dot operator, and also the notation for ranges. So it's nice to see Apple taking inspiration from the Groovy language. So that's something we are quite happy with and quite proud of. Okay, so we're good with closures. Now let's speak about lists. So, well, not much to say here because you've already seen this notation with the square brackets. So list is a comma-separated list of elements and surrounded by square brackets. We also have some operator overloading with this left shift operator, so you can append stuff to your list. So you saw already some of the examples, final, collect, etc. For maps, it's also square brackets, and the key and values are separated with colons, and then all the key value pairs are separated with commas. So you have actually the two notations here. The indexed access, so it's very much like in JavaScript, by the way. The indexed access when you use map, square bracket, and daughters, or you can also use the property notation map.daughters to add a new value associated with that daughters key. We have a notation for regular expressions, so this is creating a Java pattern. We have some special operator. This one is calling the matches method of the matcher class. The find method of the matcher class. This one is also interesting, the last one, because Groovy adds a find method on strings, and if you pass a regular expression, it's going to try to find some groups, so the zip code and the town name. It's going to find the groups in the regular expression, and it will pass them as parameters to the closure. So the match is the full match, and then you've got the zip from that group, the first group, and the town from the second group. So it's nice for retrieving elements of a string according to a regular expression pattern. We have ranges with the double dot notation, so it's going to create a lazy list of values. Here it's a list of strings from A to Z. We also have, so this is including Z, but we also have this notation with the less than sign, double dot less than sign, which is the one Apple borrowed for Swift, by the way. So here you can exclude the upper bound. You can also create reverse ranges if the left bound is bigger than the right bound. And also something which is not specific to ranges, it also works for lists as well. If you use a negative index, it will count from the end. So if you use -1, it's going to take the last element here of the range. So the last element of that 10 to 0 range is 0. If you use -2, it's going to be 1, the previous element starting from the end. We already talked a little bit about G-strings. We have different notations for strings with the G-string placeholder notation with the dollar notation there. If you've got triple double quotes or triple single quotes, you can create multi-line strings, so you don't have to use \n everywhere. So this is a poor man example of a template, let's say. If you use single quoted string, that's a plain Java long string, but otherwise, when there's if it's double quoted, I mean the door placeholders really create a Groovy length G string object, which is coerced into a string whenever you need the string. So if you pass a G string into a method taking a string, it's going to be transformed into a string appropriately, obviously. Now, a little quiz. So what this little example is going to print out. If you do system.println of 2.0 minus 1.1, I mean, if I ask my daughter, well, she's a bit young because she doesn't know yet the floating point numbers, but 2.0 minus 1.1 usually, I mean, it's supposed to be 0.9, right? But actually, in most languages, it's 0.8999999. It's kind of weird, but it's the way numbers are encoded, etc., which makes some running errors for certain operations. Another example, if you do 3 divided by 2, naturally, people could, well, unless they are programmers, people would usually expect 3 divided by 2 to be 1.5, but actually we do an integer division. So 3 divided by 2 is 1, which can be a little bit weird. But if you do that in Groovy, 2.0 minus 1.1, it's really 0.9. If you do 3 divided by 2, it's really 1.5, because by default, for such operations, when you use 2.0, we actually use big decimals. So that's why sometimes you're going to see some micro benchmarks on the web saying, wow, Groovy is super slow for math operations. Yeah, but the guy didn't know that he was using big decimal instead of floats or numbers or doubles. But obviously, if you really want to use float or numbers, you can assign those values into a double variable, a float variable, and it will be real floats and real doubles instead of big decimal. Or you can also use suffixes like D and F, 2.0D or 1.1F. It will create doubles and floats. But this can be sometimes a bit not counterintuitive for normal persons, but for developers. It can be surprising, but that's interestingly, that's one of the reasons lots of financial institutions decided to use Groovy, because they really wanted to have accurate arithmetics to avoid rounding errors. When you play with monetary amounts, you usually use big decimal because you want those rounding errors to be avoided. So that's why we've got this strange logic with big decimal by default.
Quick question, Guillaume.
Yeah.
Just about some of the strings that you were showing before.
Yeah.
In internally, are G strings converted to strings like Java strings or string builders?
So we, yeah, it's actually when we call the, I mean, in terms of how it's implemented, right? Behind the scenes, yeah, once we transform that G string into a string, when you need to do that. For instance, as I said, when you pass a G string to a method that expects a string, then we're calling somehow the toString method of the G string class. And behind the scenes, yes, it's going to use a string builder to build up the resulting string. So it's usually quite efficient, and it's also totally transparent.
Okay, cool. And a second question to that, or follow-up question. It's either one of two things. Hamit's either asking if you're allowed to wear a G string in a swimming pool, or he's saying, can you maintain a G string in a string pool?
Right.
So is there such a thing as like a G string pool where you can?
So no, there's no G string pool. Somehow we just each G string stores the various string parts of the, you know, like dear Mister, or you're the winner of the lottery, blah blah blah. So we hold those strings into the G string instance, and then we have some kind of array to hold the values of the variables which are embedded into the G string. But we don't really have a pool under the hood.
Awesome, thank you, and thanks for the question, Hamit. If anyone else has any questions, please do put them in IRC for Guillaume. Thank you.
Thanks. So back to the powerful switch, which is here. So when you use the switch construct in Java, you can use numbers like, you know, integers, shorts, etc. You can use Also, since Java 7, I think you can also use strings, enum values. But that's pretty much it in Java. In Groovy, we go a bit beyond because we allow other types to be passed, or other things to be passed to the case part. So you can say, okay, case 1, 2, 3, if the object equals to 1, 2, 3, you can say, as usual, if it's equal to the ABC string. But you can also say case string. So if the object is instance of string, then do something. Or you can use a list to say, okay, if the object is inside that list, then do something. Or if the two-string representation of the object matches that regular expression, then do something. Or you can also use closures in the case statement to say, okay, if that object, actually there's an error, it should be, I think, oh no, or it is okay, I think both is okay. If you use custom closures, it's going to use the result of that Boolean expression to say, okay, are we in that case or not? So the powerful switch case goes a bit beyond the standard switch case from Java. We have here an interesting case where we drop the parents, but we mix named arguments and normal arguments. So here you have a normal argument, and you have a named argument here. This is interesting because sometimes you've got methods which take several arguments and you don't always know. So is it the X or is it the Y? In which order those arguments should be passed to the method, you don't always know. So you can have some methods with that kind of signature, and it's quite readable. So you move the object by X and by Y. And there's a call convention for that. So if you have a method like that, it's going to call the move method, which takes a map. All the key, all the named arguments are going to be passed as key and values to the map, and the map is the first argument of the move method, and all the other parameters, which are normal arguments, will be passed in the order as they appear as additional parameters of the move method. So that's a call convention, and it's pretty useful for DSLs. Another example, you remember in my introduction, this example, move forward at 3 km/h. It's what we call command chains. The idea is that you can drop parents and dots for the case where you chain method calls. So here, move forward at 3 km/h is actually equivalent to move forward. Forward is a parameter passed to move, and the move method is going to return some value on which you're going to call the at method, which takes a parameter. And notice this other trick, which is that 3.km is actually the property notation. It's a shortcut notation for the getter, 3.getKm. And Groovy is able to add properties or methods to numbers or any type, both with runtime metaprogramming techniques or even with compile time metaprogramming techniques. And notice the operator overloading with the div operator for the slash. So ultimately the two here are equivalent expressions, right? But for your DSLs, you can decide to use that kind of syntax, which makes things pretty much, plain English, plain French, plain whatever language you're using. And next, if you mix named arguments and command chains, you can have some interesting syntax. So here, visually, you have the impression that you have check that on the left, and on the right, you want to check that vodka tastes good, right? And the call convention for that, combining named arguments and command chains, is that check takes a named argument, so that vodka is the named argument. It's going to return something. And then you call the taste method on the result of that call, and you pass good as parameter of the taste method. So that's the kind of tricks you can use to write very readable business DSLs in Groovy. So there are many other tricks. What else? We have multiple assignments. If you use that notation, parents A, B, you can do the swap case with that notation. So this is you assign to A and B at the same time the list on the right. You can be explicit, you can use types for your variables. What's interesting, what enables what we call destructuring, so it's a form of pattern matching, is that if you have a method returning some list, array, or something that's got a special method that I mentioned in the next slide, is that it's going to allow you to do destructuring. So when you call geocode, which returns a list, the Groovy will be able to take the first argument of that list, the second argument of that list, and put that in the LA and LO variables, so that you can assert afterwards that the latitude is 45 and longitude is 2.3, etc. And the nice thing is that, again, it's a convention, is that you can also have your own destructuring operator. It's not an operator, it's a convention. If you've got a getAt method with an index as parameter, you can destructure the point into several variables. So here I'm interested in retrieving the x and y values. So if I have a point that I created here on the right hand side, you can retrieve the x and y by using multiple assignment, which can be handy. So as long as you've got a getAt method, you can do that kind of destructuring. You remember the markup builder from the introduction? We also have some nice builder for JSON payloads. So with this notation, you create a JSON builder, and it's going to create a person with a name, with a list of daughters, with an address, and it's going to generate that kind of JSON payload, right? And notice how we use, again, closures nested within each other, so that you can see the level of nesting of the JSON objects. And so what's interesting is that the JSON support in Groovy is actually the fastest JSON support available, especially for the parser. In this example, I'm using the JSON slurper, so this is our JSON parser. And we're going to speak about what we call GPars expression, so it's kind of a next path notation for an arbitrary object graph, JSON graph, or XML graph, etc. So there's actually quite a bit of information in that little example, so let me go through that. So here we have a string representing the URL of the GitHub repository, the Groovy GitHub repository, so you can get the list of commits with the GitHub REST API, and it's going to return some JSON payload. Groovy added two URL methods to strings so that it's going to be transformed into a URL. And then we have this .text property on URLs, which actually does an HTTP GET, basically. You've got a full-blown REST call with just do .text, and it's going to do the HTTP GET REST call. It's going to retrieve the JSON payload, and then I'm going to parse that payload. And what's interesting is this notation there at the bottom. So we retrieve a list of commits. You retrieve the first element, then you can retrieve the commit object of that element, the author object of that commit object, the name object of that author object, all that. So this is the GPars expression. You can also mix and match things like find all, etc., all the nice methods that we mentioned before. And ultimately, what's nice is that you don't even have to create any intermediary classes to do the marshalling and marshalling, because it's fully it's a dynamic feature of the language, because we don't have to create intermediary structures to hold the values of that JSON document. So this is a pretty powerful feature. So in just a few lines of code, you can quickly go through a JSON document, in a couple of lines of code. In my examples, you saw several times the assert keyword. The assert keyword in Groovy is always enabled, so you don't have to use the -EA flag to get the assert keyword enabled, like in Java. What's nice with the assert statement in Groovy is that if you've got something wrong somewhere in that assert and you've got an assertion failure, it's going to print out all the values of all the sub-expressions of that big expression. So if you had a mistake somewhere, like the minus should have been a plus or something, you may be able to spot easily that the result of that subtraction is 29, although you expected it to be 31 because you should have used a plus, etc. So visually you see the values of each sub-expression. And this feature was actually invented by the Spock testing framework, and we got a contribution from the Spock developer to get that integrated into Groovy to have very nice assertion failure. So although sometimes you create several asserts because you want to check the various sub-expressions, etc. sometimes, but in Groovy you just use one assert, and because the result, the output of the assertion failure is pretty explicit with the sub-expressions being visualized that way, it's much easier to spot mistakes in your code and why the assertion is failing. Another one feature that I like, that's the null handling in Groovy, the safe navigation. So let's say you have an order class which got line items. A line item is made of a quantity of items, and an item has got a name. So if you create an order, so an order with a line item with 2 items, but somehow the item is null. If you do in Java, you do o.getLine.getItem.getName, you're going to get a null pointer exception. But the thing is that in Java, you just get null pointer exception. You don't have any meaningful error message, so you don't know what was null in the chain. So usually what you do is you nest if statement. So if O is not null, then you can do o.getLine. You put that in a variable, or you do o.getLine different from null in a second if statement. Then if this is not null, you can do .getItem. If it's not null, you can do getName, etc. So you either have to have a very long if with several conditions, or nested if statements. So it's very verbose. But the first thing I'd like to say here is that when you do o.line.item.name in Groovy, you will get a null pointer exception, but the null pointer exception is coming with a message saying cannot get property name on null object. So you quickly spot what was null because you look for name, okay, name on null object, so that's the item which was null. And secondly, second thing I want to mention here is that we also have a special notation with this question mark dot operator instead of the dot, is that if anything is null in that chain, this expression is going to return null. So you don't get null pointer exception, but you get null as the result of that expression. So that's what we call the safe navigation. And it's also one of the things that has been borrowed by the Swift language. And C#, I think it's C#6, the next C#, or was it already in C#5? I never remember, which is also using that notation as well. So even Microsoft steals some of the nice features of Groovy. And what's nice as well is that we're going to be reusing this safe navigation with what we call the Groovy truth. In Groovy, you can actually even customize the truth. That's quite powerful, especially for politicians, lawyers, etc. So the Groovy truth, so it's a bit like the falsiness and truthiness in JavaScript. Basically, anything that's null, empty, zero side, of value 0, etc., can be coerced to a false Boolean value. And otherwise, any object which is not null, any non-empty string, any non-empty list, a number which is not equal to 0, is going to be true. So that's the Groovy truth. So notice that the assert statement expects a Boolean expression, and we passed something which wasn't a Boolean. So that's when the Boolean coercion mechanism kicks in, and we call the Groovy truth to somehow transform that expression on the right side of the assert keyword to transform them into a Boolean expression. So you can use that with if, while, etc. And I mentioned that you can customize the truth because there's a convention which says that if you have an asBoolean method which returns Boolean, you can say things like assert new account. So it's going to be true if the account is not disabled, and if the account is disabled, then the account will be coerced into a false Boolean value. So you can customize the truth and have your own types be coerced into a Boolean value if you follow that convention. And then you can pass the account into while, if, etc. So you don't have to do if account is disabled or that kind of things. You can just do if account and go right away. And last but not least, related to Groovy truth, Boolean coercion, etc. That's the Elvis operator. If you put your head sideways, it actually looks like an Elvis smiley. That's the Elvis operator. Basically, when you've got two variables, x and y, and sometimes in your code you want to do, okay, if x is not null, if its size is not 0, then you return x, and otherwise you return some default value, y. If you apply Groovy truth, x different than null, well, x, if it's not null, it's a shortcut for x different from null. And similarly, if x size is not 0, you can just do end x size. If you go a little bit further, anything that's not null of size greater than 0, etc., then you start to see a pattern emerge. So if x, then x, otherwise y. And it's actually like the ternary operator. So if x is not null of size not 0, etc., then you're going to return x, or you're going to return y, right? But we thought, okay, there's a bit of repetition there. You repeat x twice. So what about compressing that a little bit? And we actually crashed the colon into the question mark, and it became the Elvis operator. So it's a kind of default operator or something like that, but it's called Elvis. So if x is not null of size 0, etc., then you're going to return x. Otherwise, you're going to return a default value, which is y. That's the Elvis operator. And beyond that, Groovy, so you can do, so I didn't go into the dynamic metaprogramming capabilities of the language, but I mentioned the static, the compile time capabilities, the compile time metaprogramming capabilities of Groovy with what we call AST transformations. So when you compile Groovy code, in memory, at some point, you've got an AST, an abstract syntax tree, representing the code of your program before it's getting compiled into bytecode. And you have some hooks in the Groovy compiler to get, during the compilation process, to get access to the AST and potentially to transform the AST into something else. So just to give an example, remember the Groovy properties. Somehow, at a certain stage, in the Groovy compiler, we generate a getter and a setter method. Although they were not present in the AST, we have a property node somehow in the AST, but somehow the compiler does some further code generation and that kind of thing. And Groovy features tons of useful AST transformations. We saw one with the @immutable, and I'm going to go deeper in that one in a couple of slides. We've got ones like package scope that I mentioned, if you want to have a package scope for things like fields, methods, etc. And grab for grabbing dependencies. And I'm going to show the @immutable one in more details. So if you want to implement immutability by the book, like in effective Java, your class should be a final class. You should have private final backing fields. You should be doing defensive copying of collections if they are fields of your class, so that you return a copy, so that nobody is going to alter the internal collections, etc. You also need to have a nice equals and hashcode method. Doing all that can be error prone if you want to do it yourself. If you do it in Java, so it's probably not very readable on your screen, but if you do it probably in Java, the person class with the string name, string age, etc. So you've got the final class, the final field, the implementation of hashcode, of equals. You've got the getters, but no setters because it's immutable, etc. It's quite a bit of code to write. So this bit of Java here is also valid Groovy code, obviously, but we can write that more succinctly if we use the @immutable code transformation. So you just annotate your person class with @immutable, and it's going to make your person class immutable. It's going to make the class final, the backing fields final, to only generate a getter but no setter. It's going to create an equals hashcode method, etc. So it's really the compiler that's going to do the implementation of that pattern itself. So it's not your job to do that. It's going to be the Groovy compiler that's going to write all that code for you. So instead of the 20, 30 lines of code, you just do an @immutable annotation, put that on your class, and you've got an immutable object, an immutable class. We have some other useful ones like @memoized, which is interesting. It allows you to memorize the previous outcome of invocations of your method. So for Fibonacci, when you call Fibonacci of n, it's going to call Fibonacci of n-1 and n-2. But if you call Fibonacci of n-1, it's going to call again Fibonacci of n-2, etc. So that you call several times the same Fibonacci call. So fib of 0 or 1 is going to be called several times. So memoization, we implement the memoization pattern with that trigger, this annotation triggering the code transformation to actually put the to use some kind of cache, least recently used cache, to put the previous outcome, the previous invocations of the method with the same value parameter to return the value from the cache rather than doing that call and computation all the time. What's interesting with code transformation, HT transformations, is that they allows you to be lazy, because that's the Groovy compiler that's going to do the job for you of implementing a pattern, of doing code generation for you. It also allows you to have more concise code, more readable code, because you've got much less code to look at. So it's usually easier to maintain, and you don't have to worry about it too much, because that's the job of the Groovy core team to take care of the correct implementation of those transformations, at least the ones built in Groovy, but you can also create your own transformations. So it's really nice to make your code much more concise and implement existing patterns or create or do code generation, etc. And two additional, they are actually implemented in the form of HT transformations. Two additional such transformations are type checked and compile static, which allows you to do static type checking on your code and use static compilation. So it's pretty advanced stuff. I won't go into details too much, but the type checking capabilities of Groovy, when you annotate a method or a class with @typecheck, it's very advanced and very fine-grained. So there's some really clever logic there to really follow the types that you are using in your implementations, in your code. So I won't go into details, but it's interesting to know that you can even represent, the Groovy compiler even represents types which cannot be written with the Java type system. So it goes a bit beyond the Java type system. And once your code can be statically type checked, we can also statically compile it. What's interesting as well, as shown in the little bubble, by the way, there's the grumpy dwarf, because initially the code name of that feature was grumpy, because we wanted to make the Groovy compiler grumpy so that it reports more errors at compilation time. you can even extend the static type checker to support dynamic features. So if you've got DSLs which are highly dynamic, etc., you can even create your own extension to the type checker to type check code which is dynamic, basically. And for the static compilation, we generate pretty much, so if your code type checks, you can use add compile static on methods, on classes, etc. And what the Groovy compiler will do is that it's going to bypass the Groovy runtime system, and it's going to create pretty much the same bytecode as JavaScript without going through the runtime, and it will give pretty much the same performance as Java. So I have some examples. So the figures are pretty old. I have not updated those figures recently. But I wanted to show you the progress in terms of performance for Groovy. So we looked at 3 micro benchmarks, which were typically, I mean, the worst case scenarios in terms of performance for Groovy, because of recursive calls, because of polymorphic calls, because of things like number arithmetics, etc., which were doing lots of boxing, etc. So if you looked at very old versions of Groovy, like Groovy 1.7, etc., you could see a huge performance difference between Java and Groovy 1.7. Then we introduced some optimizations for things like primitive type calculations. We introduced in Groovy 2.0 static compilation, and progressively you can see that, I mean, the performance with Java, I think it was with Java 7 that I tested that, and Groovy 2.03 or 4, you can see that Groovy and Java pretty much have the same performance. Sometimes it's a bit slower, like by 20, 30% compared to the equivalent Java implementation, but it's not such a big difference. And perhaps with Groovy 2.3 or 2.4, the latest versions of Groovy, perhaps this one there, the binary tree example, is perhaps now as fast as Java. I haven't double checked. But yeah, basically Groovy can be as fast as Java as needed, especially if you use static compilation. And I'll finish with the last section with just quick few words about the community, because there's a really blossoming ecosystem of projects around the Groovy project. So there's the Groovy language, but there's also the Grails web framework, the web stack. There's also the Griffon framework for creating desktop applications or JavaFX applications, etc. With an MVC approach like in Grails. There's the Gradle build automation solution, and many other interesting projects like GPars for everything about concurrency, actors, etc. You've got CodeNarc for static code analysis for Groovy, Spock for testing, etc. So there are many. So it's just the most famous projects. There are many interesting projects in the Groovy ecosystem. The last kid on one of the last kid on the block was the Groovy JVM, the Groovy Environment Manager, which allows you to, it's a command line tool which allows you to easily switch between versions of different tools, like different versions of Groovy, Grails, Griffon, Vertex, Spring Boot, etc. So you've got a command, you do JVM, use Groovy, whatever version, you can switch between versions. That's pretty handy, especially for us Groovy core developers when we want to check that a bug exists or not in this or that version. But sometimes when you switch between projects, it's easy to use JVM to switch between projects which use different versions of Groovy, Grails, Spring Boot, etc. We've got the Spock testing framework for enterprise testing. So we saw the example before already, so I won't give you more details about that, except that here I properly added the grab statement. The grab annotation, sorry. The grab annotation actually allows you to, you don't have to create a full-blown project just to run a Spock test. If you put that in a Groovy file and use the Groovy command to execute that test, it's going to fetch the dependencies out of Bintray, JCenter, or Maven Central, so that you get the dependencies in your class. So that's nice for, especially also for things like when you do some scripting in your shell, etc. You don't have to create a full-blown project just to depend on some useful library. Okay, so I mentioned the details there. Ratpack, that's a pretty recent toolkit based on Netty for fully asynchronous applications. It also implements the reactive streams APIs. So it's a very powerful and efficient framework. What's interesting as well is that, so there's a very nice Groovy layer that you can use, but you can also use the Ratpack framework for your microservices, your reactive apps, etc. from Java as well, because it's got a Java API. But there's some nice syntax sugar for when you use Ratpack with Groovy. I'd like to mention Jeb for browser automation. So it's combining WebDriver and Selenium with a jQuery kind of notation plus Groovy to do things like web functional tests or web scraping, etc. So you can drive the browser with this nice DSL. So go to that URL. You've got the jQuery notation to find the text of the H1 tag. You can also retrieve a form, and you can fill in the fields of the form. You can click on the button to submit the form, and then you're going to be redirected to some admin section of the site, and then you can check that there's a H1 tag with the admin section in the H1 tag. What's nice is that if you combine that Jeb plus Spock, you can have some very readable tests. You also have the notion of page objects in Jeb to avoid having fragile and brittle tests when you use when the URL changes, or when the path in the HTML document changes. You can wrap that into some special objects, and then you can have some given when then style thanks to Spock, and then have the logic for going through the page, clicking, filling forms, etc. So in summary, so Groovy is Java's best friend because it's so easy to learn for Java developers thanks to the flat learning curve. It goes beyond Java in the sense that it goes beyond in terms of syntax and tries to simplify certain mundane and common tasks to make the code more concise, more readable, more expressive. There are various call conventions or tricks, metaprogramming tricks, to allow you to create domain-specific languages with very readable business rules. It's the alternative language which provides the most seamless and transparent Java integration. There's really no barrier to cross, so you don't have to. I mean, a Groovy object is really just a Java object. You just manipulate it from Java the same way. There's no barrier to cross. You don't have to convert from one object in a certain language into another object. That's really totally transparent. Groovy is a multifaceted language because it's at the same time an object-oriented language, but also a dynamic language. It can be as type-safe as you want it if you use static type checking. It can be as fast as you need it with static compilations. And thanks to closures, to all the methods we have around collections, etc., you can make your code as functional as needed, thanks to closures being first citizens of the language. And there are various use cases like for scripting stuff from your shell, for business languages, for extending a Java application with some special customization or configuration logic. Or you can also write full-blown applications with some frameworks like Grails, Ratpack, Gaelic on Google App Engine, Griffon for desktop kind of applications. And that's it. So thanks a lot for your attention. And if we have some questions, I'm happy to answer those questions.
Hey, Guillaume. We're actually well over time right now, so what I'm going to suggest is that we do questions in IRC, in the hashtag virtualjug on Freenode. If anyone else has any other questions and they have to run, we can also take them in the comments of the meetup group. But we do have the couple which were what's the next steps really if someone wanted to learn Groovy in more depth in terms of actually grabbing an open source project, or are there any projects they're starting out that needs help and things like that?
I mean, there are two things. So for those who want to learn more about Groovy, there's obviously the Groovy documentation, the Groovy website. There are some very nice books like Groovy in Action, Groovy Programming, etc. There are some interesting resources there. There are also resources like Groovy Cones, Koans. If you want to have some, modify some examples and see how they work, etc. There are some interesting resources like that. And if you want also to contribute to Groovy, to learn more about the projects, I mean, the whole ecosystem is always looking for, contributors, etc. So we're always open to further contributions. I mean, we studied a new documentation effort for the Groovy language, for instance. That's one of the places where we're looking for contributions. That's basically my.
Okay, and if you wanted to drop me any of those links, I'll happily drop them around the mailing list or on the comment section as well.
Sure.
Awesome. So for now, thank you very, very much, Guillaume. That was like an absolute masterclass in Groovy. It's an absolute pleasure to have you speaking here on the VJug. Couple of other things that I'm just gonna mention before we close up. The next session is on Tuesday next week, the 9th of December, and that is Salon for Java developers, and that is being given by Gavin King. Gavin works for Red Hat, the company that do a lot of the work behind Salon. And just to reiterate, if those of you didn't hear our announcement last week, we have James Gosling, the virtual jug, and that's going to be on the 22nd of January. And I'm working with James to get the abstract and title ready so that we can put it on the meetup site, so we can start getting all those +1s come in at the speed of light, I'm sure. So yeah, I'll just say thanks again to Guillaume. That was an absolutely awesome session, and we're very proud to host you on a humble site.
Thanks a lot for inviting me.
No problem at all. Thanks very much, VJuggers, and see you next time.